So as we continue working with polynomials, we're going to move into the multiplication, and then with multiplying, we're also going to have factoring involved. And we're going to write, simplify, and we're going to evaluate these algebraic expressions. And we're able to do this, and we're going to use some of the same properties that we've been using all along. For example, the distributive property, when we are multiplying binomials and monomials and polynomials, we're going to use the distributive property to simplify that expression and create a new equivalent expression or polynomial. And in factoring, what we're doing is we're reversing that multiplication process. And we've used the that monomial. Let's see here. Monomial can be multiplied by a polynomial in that distributive factor, and then what we do is we reverse that distributive property. Factoring a polynomial reverses that multiplication process, because the first thing that we're going to do in factoring a monomial from a polynomial is find the greatest common factor. And we'll get some practice with that, but it's just an extension of what we already know, and we are just applying it to a little bit different process or a little bit different example. So looking at this as we, let's see here, a greatest common factor. Well, let's just move on, and I'll talk about the vocabulary words as we go. But we have multiplying a monomial and a trinomial, and what we're doing is we're multiplying a monomial to a polynomial there, and it says what is a simpler form of this expression. And what we're trying to do is we're trying to get rid of the multiplication. Anytime we're simplifying, we're getting rid of our different math operations. And we should be able to recognize here that if I have something outside the parentheses, that should be that I'm multiplying, right? The parentheses are a understanding that is going to be multiplication, and that's what this x stands for right there, the multiplication, because I'm going to multiply everything in that trinomial by negative x cubed. So as I do that, I use the distributive property, and I have negative x cubed times the first term, times the second term, and then again times the third term here. So what I've done is I've written out that distributive property multiplication. And then I've simplified here, and I had negative 1. I have negative 1, negative 1, negative 1. So negative 1 times 9 gave me negative 9, and then of course, since I'm multiplying like bases, my x's, technically I am going to then add their exponents. So that's what I'm showing you here. I have negative 9x to the 3 plus 4, plus negative times a negative give me a plus, and then I have negative 1 times negative 2 is going to give me a 2, and then again x times x, so I add the exponents, and then negative 1 times 3 is going to give me negative 7, and then I don't have a variable there, so I'm just going to multiply it by x to the third, and I'm going to go ahead and simplify my exponents and rewrite down here. So I have negative 9x to the 7th. I had to take a quick break there, so a big old spider coming across the floor by my feet. That wasn't going to last very long. So again, so I've rewritten the expression. So I have negative 9x to the 7th plus 2x to the 6th minus 7x to the 3rd. So hey, not to say that my house is dirty. It's been raining, so some of the dogs bring other creatures in. So applying this distributive property, let's take this and we're going to go ahead and do some distribution here. So we have to take this 5n and multiply it times everything that's in the trinomial. So we're going to multiply it by all three terms. So again, distributing it to all three, and in distributing it, we're going to be multiplying it. So I have 5n times 3n cubed plus 5n times negative n squared plus 5n times 8. And then I can go ahead and do my multiplication here. So I have 15n to the first times n to the third is going to give me n to the fourth, minus negative 1 and 5 is going to be a negative 5 into the third because I have 1 plus 2. And then that is going to give me, then down here is going to be 5 times 8 is going to be 40 in to the first, or just 40 in. And there you go. I've done my distributive property, and I've been able to work out all my multiplication there. Let's see, so moving on. Finding the greatest common factor. Now, when we are able to find the greatest common factor, we're going to, basically right here as I've noted, what does each term have in common? So as I break these terms down into their prime factors, I am able to take 5x to the third and break it down into 5 times x plus 25 times x squared, which is going to be 5 times x, plus 45x, which is 5 times 9 times x. So as I break those down, we see that what they have in common is going to be, well, they all have a 5 and an x, so that would be my greatest common factor. So as I pull the 5x out, what's left behind? And it actually here didn't even ask me to go ahead and find the remainder, but I've done that, and that keeps us moving forward later on. But, my greatest common factor is 5x. When I pull, and I'm done, but when you pull that out, what do we have left behind? Well, I have x squared plus 5x plus 9, and that's what's the remainder there. So from my trinomial, when I factor out the 5x, that's what's remaining from my trinomial. So when I look over here at this next example, what is the greatest common factor? And I need to see that what do each one of them have in common. So I have 3 times x 4 times, right? Minus 3 times 3 x times x minus 3 times 4x. And so when I look at what do I have in common, well, I have a 3 in common. And then I also have an x in common. And that's what they all have in common. So I can factor from each one of those terms, I can factor out a 3x. That's going to be my greatest common factor. Because we're not worried about just numbers or just letters. We can have a combination of both numbers and letters. So there's my greatest common factor. And then, of course, we could see left behind, we have, looks like x cubed minus 3x minus 4. But we're not asking for that, right? They're only asking me that this 3x is my greatest common factor. Let's see here. So now factoring out a monomial, and it says find the factored form of each expression. So now we're going to factor out that monomial, and we're going to have that remaining trinomial left behind. Because if we started with a trinomial, we're going to continue to have a trinomial as long as we're just factoring. So if I look here, what I've done is I've taken each one of my terms. I have 4x to the fifth minus 24x to the third plus 8x squared. And I've broken them down into their prime factors. And 4 is not prime, but I saw that that's what's in common there, so I didn't need to go any more. So I have 4x and 5x's. I have a negative 6 and 3x's. I have a 4 times 2 times x. And then so I found the greatest common factor. The greatest common factor turns out to be 4x. So as I factor my 4x from each one of those terms, I'm looking to see, okay, well, what's left over? So here is my 4x as I pull it out, and then my first term is I'm going to have x to the fourth. And then my next term, after I factor out my 4x, I'm going to have negative 6x squared. And again, my last term is going to be 2x. So I'm going to have plus 2. Goodness, I got that wrong, huh? So I need to make sure I make that correction right now. And hopefully I catch this for class. but 2x is left behind. Always good to check your work, and that's right there. Now, if we wanted to check this, anytime we factor, we can turn around and check it by just reversing that and doing the multiplication process. And so if we were to multiply that out, sure enough, that would become 4x to the 5th minus 24x to the 3rd plus 8x squared. So now we know that it would have been correct. Did not have it correct before. Okay, so in finding these factored forms, let's see. Let's go ahead and look at this next example. We have 9x to the 6th plus 15x to the 4th plus 12x squared. So we know that looking at my greatest common factor, well, see, I have 9x to the 6th, and I'm going to factor 15x to the 4th, and I'm going to factor 12x squared. Okay, now that I've factored those, looking to see what they have in common, well, it looks like they all have a 3 in common, right? And then they also all have 2 x's in common. So it looks like my greatest common factor is going to be 3x squared, okay? So as I have 3x squared times what is left over, and I'm going to have 3x to the 4th plus 5x squared, and then plus 4. There you go, and there's my factored form. I've factored that polynomial. We have a greatest common factor and then the trinomial that's remaining. So that's how we are able to factor those. And then this is, what is this? Negative 6x to the 4th minus 18x cubed minus 12x squared, written as a product of a polynomial with positive coefficients and a monomial. Okay, well, if I want my polynomial to have positive coefficients, if you notice here, everything has a negative. So that means I can factor out a negative, and that will leave behind the positives. Well, if we just take it and we start from the beginning and work through, we have, we have negative 6x to the 4th. We have negative 18x to the 3rd, and then we have negative 12x squared. And you might recognize right now that, well, the greatest common factor in numerical is going to be a negative 6, and then the greatest number of variable that we can pull out is going to be x squared, but we'll go ahead and write it out. Okay, so looking here now, we can see that my greatest common factor is going to be 6x squared, or negative 6x squared, negative 6x squared. And then my remaining behind will be x squared, it will be 3x, and it will be 2. So as I go to factor that, my greatest common factor monomial is going to be negative 6x squared. And leaving behind a polynomial with positive coefficients, we will have x squared plus 3x plus 2. And there you have it. That is our simplified expression meeting the criteria of the question. Wouldn't be algebra without a word problem. So here, when we are factoring a polynomial model, all right, so they've given us some words, they've given us a picture. We're going to go ahead and figure out what it's saying. So, helicopter landing pad, helipad, okay, is marked with a circle inside a square. So we have this circle inside what I've tried to indicate was maybe a shaded in red square. So it's visible from the air. And then what is the area of the shaded region here of the helipad? So write your answer in factored form. Well, if we look at it, we have a shaded square where we removed the shade from the circle. So what we can do is say, well, the shaded area of the square minus the area of the circle. So area 1 is going to be the area of the square. Area 2 is going to be the area of the circle. So area 1, we can see here that the square is going to be a side length of 2x. And the formula for area is, my side squared. Area of a square is going to be one side times the other side, or my side squared. So my side is 2x. 2x squared is going to end up being 4x squared here as I do my exponent rules. And then the area of the circle, well, remember the area of a circle is going to be pi r squared. And they've given me the value of r, which is my radius, and they said my radius is x. So the area for the circle is going to be pi x squared. So as we do some replacements here, remember we will have area 1 minus area 2 is going to be the area of the shaded region. So area 1 was 4x squared minus pi x squared, and that is going to give us in factored form, right? In factored form, we can factor x squared out of both of those, leaving behind x squared times 4 minus pi. And that's my factored form. Now, if we go to do that here together, it says, so suppose the side length now is going to be 6x and the radius is going to be 3x. Okay, so in this, right, we're going to have 3x and 6x. So then my area of my shaded region minus the area of the circle is going to be, well, area is going to be 6x squared minus pi 3x squared, and that is going to equal, remember the exponent goes to both, so we're going to have 6 squared, which is going to be 36x squared, minus, well, we have pi, and then we're going to have 9x squared. And we can factor out now, gosh, we can factor out of these, we have a greatest common factor of a 3 and an x squared. So if I were to factor 3x squared, that would leave behind here a 12 minus 3x squared. That would leave behind 3 pi. So I do believe that the answer there in factored form for this new region is going to be 3x squared times 12 minus 3 pi. There you go, and there's the factored form of that new region. And what we're doing here is we're using the same properties that we've been using before. We're looking into our exponent rules using the distributive property. We're using some division and factoring. But hey, these are all skills that you know. We are just applying them in a different facet. We're throwing it into algebra and we're putting a variable in there. But yeah, these are things that we have the capability of doing. We just have to practice them so they become a habit when you see a certain problem, how you simplify. Practice makes proficient.